Hi, this is Tim Kulbago from ImageIQ, and I'm here with our Chief Science Technology Officer and Founder, Amit Vasanji, who's going to join us today to talk a little bit about mouse fundus lesion analysis, specifically in the preclinical space. I mean, fundus imaging is used in a lot of different places, but we've set up this series of webinars for you to really talk a little bit about some of the preclinical imaging assays that we see in the industry that people are doing. And we thought we'd share some of our expertise, talk about the assay a little bit, talk about how people are acquiring it, who's acquiring them, what are some of the pitfalls of the assay, and then what kind of analysis can be done with the assay, because that's obviously important to us as an analysis company. And if you get good data from your images, then good things happen, right? So that's kind of the story. So with that in mind, why don't we get started, Amit? Sounds good. And we'll kind of go over this. So to start out, I guess, what kind of folks are performing this kind of the fundus imaging, especially in preclinical? I know I hear about it in the clinical space.
For the most part, it's anybody that's interested in any ocular disease. So if you're looking at models for diabetic retinopathy, for any sort of AMD, dry AMD sort of models, that you can use this sort of analysis. It's pretty quick and easy to do. It's not you can use OCT, but that takes a little bit longer to do. This is a single snapshot. You can get some data. OCT obviously will give you more, but a different kind, right? So. And then, usually some people are often using it just to check whether they don't have a phenotype in the eye. So if you've got an animal and you're pretty sure that it doesn't have any sort of issues with the eye, you go do a quick sort of scan to make sure and confirm it.
So it's as much a rule out as a rule in kind of thing?
Right.
Okay. Right. Is that only used for people who are doing like genomic work or something like that? Or
Generally, yeah.
Generally? Okay. Okay, that makes sense. That's super cool. And the images you get are, it's kind of fun, but it's a picture.
Yeah.
It's not, we think medical imaging, you always think radiology, right? X-ray, CT scans, MR, but this is actually a picture.
Right.
So maybe we can talk a little bit about how people actually take these pictures.
Yeah, it's just a fundus camera that you're taking an image of. It's not too hard. It takes a little bit of a technique to actually get it set up so that you can do it fast enough across a lot of animals, because you're usually going to set this up one time and just acquire a bunch of images.
Okay.
But once you have it down, it's a fairly straightforward process. And it's, the traditional way of doing it is sometimes if people use ophthalmoscopes, you don't get a very good image of the eye using that. The fundus is much easier. And it's also easier than doing an OCT, which requires a lot more setup time.
So when you're doing this with, in the preclinical space, obviously it's different, you ask a patient to sit still, right?
Right.
These must be pretty small cameras, right?
Yeah. And generally you'll have to put the animal under. Sometimes if you got enough skill, you might be able to hold the animal or the mouse and then actually take an image of it too. So it just depends on what you're comfortable using. So.
Got it.
And I think there's techniques that if you do a search on PubMed, you'll probably find a whole bunch of different ways of actually doing this. But you'll have to put gel on the eyes, make sure it doesn't dry out, and things like that.
Got it. Now this is fundamentally, you referenced OCT, but the fundus stuff is fundamentally a two-dimensional image, right? So what I guess it's kind of the same thing as when you talk about doing analysis on X-rays. You have to realize what you're dealing with when you're talking about a two-dimensional image, so that you can think about getting the right data and understanding what you're looking for in the acquisition, right?
Right. It can be pretty noisy depending on how you acquire these images. So generally, the rule of thumb is to take multiple frames and average them together, so you get a much cleaner image.
Okay.
Obviously, you want to avoid motion. So if you're moving or the animal's moving, you're going to get a bad image.
Right.
You want to make sure it's centered, so you don't get shadowing on any part of the eye, which is going to affect how you.
Is this a lit? When you talk about shadowing, is it lit? Is there a light that goes?
Yeah, the light goes into the eye.
Okay.
And there's a camera on the other on the back end, so it's acquiring an image.
Got it. And it's not video. When you talk about averaging multiple images, it's not really video. You're actually, you're kind of snapshotting.
I think there are some scopes that actually do a video, and then they're using the frames to do the averaging. For the most part, I think it's acquiring multiple images and then averaging.
And you average them later, or
usually the scope does it.
The scope does it.
Yeah.
But
it takes longer to do the imaging when you do that.
Right.
So, and also, if you're doing that, you have to really make sure you're not moving, or otherwise you're going to get a really blurry image.
Real blurry. Yeah, that makes sense for sure. So when you take the image, and we've got some pictures up here on the screen, and there's some highlighting of some of the biology, the lesions and the optic nerve and the vasculature. What is kind of the current standard of analysis? What are folks doing? What are they looking at when you see an image like this? And
right.
From what I understand, we've worked a little bit with some of the folks who do a lot of fundus imaging at I think Jax and those guys, and there's some real challenges when you look at this, right?
Right, and I think this is an example of somebody that actually tried to use an ImageJ to actually do the analysis, but it's tricky because you've got this underlying intense image that's caused by unevenness of the actual eye itself. So you sort of this haze that's sort of uneven through the eye, and then on top of it you've got lesions sitting on top of it. So trying to get the lesions but not the rest of that halo is tricky.
Okay.
Right? And so that's what's going on here. I think the researcher used a threshold and said, well, I'm going to try to get as much of the lesions as I can without picking up the rest of the halo. But then you miss, like on the bottom of the screen, you're missing a majority of that lesion on the bottom of the screen.
Oh, I get it.
And so
even though it's got some of it.
Right.
You're talking about the bottom left.
Right.
Yeah, okay.
And so it just makes it trickier. And so when you're doing that, then you're adjusting that threshold every time you load a new image up, and that's obviously going to add some sort of bias to the image.
Bias to the situation.
But the image that you see on the screen is generally what you're looking at. You're looking to see how many of the lesions are. In most cases, people are just scoring them on a scale and say this is bad or good or normal, right?
Got it.
And there's no real quantification that's going on. But this researcher did actually try that, and not with much success. So
how do you deal with things like, you can see here you got the optic nerve in there. Does that create a problem?
It does. So you see that there's a shadow in there. Sometimes the optic nerve is lit up too, so you get a bright area within there. So what you have to do is have something account for where the optic nerve is. Also segment out all the vessels, because the problem with the vessels is at the edge of every vessel you get this. Sometimes you get this shadowing, and sometimes you get a bright edge. And that bright edge will look like a lesion to a threshold. And so you have to eliminate that as well.
Got it.
It becomes a little easier with the detection with that because there's no macula in these animals. The humans have a macula, so the center of your eye is actually the macula. In this case, the center of the eye is the optic nerve.
Is the optic nerve. Got it. That makes sense. Well, one of the things that we like to talk about when we do this, and it's a little bit of self-promotion. So let's just kind of call it what it is. Right. But we build this thing called Image Quantify. The idea behind ImageQuantify.com is it really is kind of self-service for this image analysis. You grab your images off your Fundus camera, you upload them to ImageQuantify.com. It does the analysis for you, and then sends you back your results. So I guess the question is, when I'm looking at those images, I'm obviously not trained. We've talked to some of our friends in this space who do these, and they say, they will have people look at hundreds of images before they're considered trained to do this. Right. And then they're still doing. Maybe they're using software. Maybe they're doing some kind of manual analysis. What kind of data can someone expect if they go to the Image Quantify site? And what kind of parameters are they ended up getting?
You get basically the algorithm goes through and segments out the optic nerve and then finds where all the vessels are. It uses those to eliminate any of these artifacts that we mentioned before, and then it goes and segments out all of the lesions, and it flattens the image so you don't have that issue with the bright sort of uneven halo in there.
In your mind, it looks like that.
Yes, and so it's finding where all the lesions are. And once you've segmented the lesions, you can count how many there are. You can count how big they are. You can count or measure how intense they are, and it's basically you can generate a massive Excel sheet with a bunch of numbers in it and then plot histograms, which is the most valuable way of generally looking at it.
Okay, so the output is generally kind of a histogram based.
Right. Because if you did a average of lesion size and you had one really big lesion and a whole bunch of little ones, it averages out to be the same as another image that had a bunch of medium-sized lesions. So having a histogram really tells you if there's any sort of deviation in some really large lesions.
Got it. So, that makes sense. Very, very cool. And as part of that, though, we also offer some pretty cool overlay images, right? And we talk about this in a lot of these videos that, you get the data.
Right.
And that's great. But then how do you know what the data, what's it looking at? How did it work? Because to be fair, just like people make mistakes, software can make mistakes. It happens, right? Did it work, and are we looking at the right thing? So maybe you could kind of walk us through what some of the overlay images look like.
Yeah, it's just exactly, these are output images from the actual algorithm. And so it runs an image, it spits out the overlay of where all the lesions are. It also spits out an image that shows you where it segmented the optic nerve and the vessels. And then it puts those together too. So the vessels and the optic nerve are sort of car, the wheel
Okay.
in there is in blue, and so you can see it and compare it to the data that you have in the Excel sheet. You can also validate whether the algorithm worked or not.
Right. So, okay, speaking of that, that's a great question, because I know I volunteered for some of this stuff. But how do you go through and validate this kind of algorithm? I mean, what because at some level you're comparing. Maybe it's not apples to oranges, but it's close. I mean, somebody who's giving you an objective assessment versus how do you get that data validated?
Right. So there's two parts of this. So when you're first writing the IQ bot, which is this Fundus IQ bot, you have to get enough images that are representative of an entire cohort of animals, because every animal is slightly different, and the image acquisition is slightly different too. And so you want to get a wide range of that just to make sure that a fully automated solution is going to actually work. So once the algorithm is trained and it spits out all of this data, you need to have somebody attest to whether it's accurate or not, right? And generally, it's the observer. There's no known, fundus whisperer that will tell you that this is the right way to actually segment the lesions, and this is the perfect way to do the analysis. So generally, you get a bunch of people together that have been trained to on a few images that have been told that this is what a lesion looks like, and they manually go through and outline them. So, and
that's a lot of fun.
Yes, that's usually when I leave the room and then laugh about how long it's going to take them to.
Yeah, good luck doing that.
And then what we do is compare the numbers that the observers are generating to what the algorithm is generating. And within a couple of standard deviations, the algorithm should fall somewhere between where the observers are counting it. Right. The observer is going to have a wide range. It's just generally that's how it works.
That's how it works. Right. Yeah. But at least the software will give you the same answer on the same image.
Exactly. Right. And that's the biggest thing here is consistency, because there's going to be some lesions where you're not quite sure it's background or it's actually a lesion, but the algorithm's going to use the same rules every time.
Every time. That's super cool, and it's fast.
Right.
And in terms of our price model, what we like is it's fee per image. Right. There's no sense of buying a big software package.
Right.
Well, I think that's what we've got for today. Do you think anything else we should talk about?
No.
That was a pretty good. Overview of fundus imaging. So, hey, thanks very much again for watching. We like to do these just to share the experience that you and your team have, and we've seen a lot of these imaging and a lot of the images, and a lot of people. They work so hard on their science, and imaging is part of their toolkit, but they don't really get into the depth of the imaging. So hopefully you picked up a few pieces of information that will be valuable.
Yeah.
If you have any questions about your assay or use an image quantify, visit the website, give us a call, drop us an email. We always love talking about imaging, so that's always fun. And thanks very much. Great.